Good morning, Algebra 2 students. Welcome to Unit 8, Day 5. Today what we're going to be doing is we're going to be looking at graphing logarithmic functions. Before we go ahead and take a look at that, what I would like you to do is take a minute and go ahead and try this quick warm-up question. Hit pause and then hit play when you're ready to see the answer. See how you did. All right, let's see how you did. So take a look right here. As we read this question, this is our initial amount that we're starting with for our loan. Notice how it says 5%. Make sure you always change that to a decimal to 0.05. Notice how we have that it says compounded continuously over the life of the loan. So recall your formula for compounding continuously is, I call it your PERT formula. So your total amount that you have at the end of the loan is a P. P is your principal. That's the amount that you started with. E is always just a number that's there. R is your interest rate as a decimal, and T is the amount of time. So I call this my PERT formula. There used to be a shampoo called PERT Plus, so that's why how I remember the compound continuous is PERT, okay? So once we fill all of our numbers in, you should have gotten $1,792,675.63. All right, so what we're going to take a look at next is we're going to take a look and see where exactly that E comes from. If you recall, this portion of your formula, 1 plus 1 over n, actually comes from your compounded formula for your interest, that your amount is equal to the amount that you started with times 1 plus 1 over n, all raised to the t. So this portion of your formula is actually where the letter E comes from, and let's see why. Now, this is your formula whenever it was not compounded continuously. So basically, how did we go from this formula right here to our PERT formula right here to use that compounded continuously formula? So what we're going to do is we're going to take and we're going to plug in bigger and bigger and bigger values of n. So what we're going to do is we're going to take 10 to the first and we're going to plug that value in for n. When we do that, we get 2.5387. Then what we're going to do is we're going to plug in 10 to the second in for n. When we do that, we get 2.7048. Then we're going to plug in 10 to the third into n, 2.7169. Then we're going to plug in 10 to the fourth for the n. Now notice what's happening as you plug in bigger and bigger values. It's kind of leveling off. We have 2.7181, 2.7182, 2.7183. So this value right here, this whole portion of this equation is leveling off at the number 2.7183. So that whole portion right here, when this levels off, as I plug in bigger and bigger values of n, that is going to be your value of E. So the natural base E is an irrational number. It's estimated to be about 2.718. Like I said, it comes from this portion of your formula by plugging in bigger and bigger values of n, okay? So as n approaches infinity, so that just means we plug in 10 to the 6th, 10 to the 7th, 10 to the 8th, this whole portion of that interest formula approaches 2.718, which we're defining to be E. So basically now we have a formula, we have an exponential formula where E, we write it as E, but E is essentially the same thing as 2.718. So now we know exactly what that E value means, okay? So now what we're going to do next is we are going to graph are functions of E. And basically functions of E is they are the exact same thing as an exponential function. Instead of having a base that is, any given number that we choose, our base for our exponential function is going to be E. And that base of E is about 2.718. Okay, so make sure you add a set of parentheses around right here. That's missing. So if that's not in your notes, please make sure you include it. So let's just take a look at our general form of E. This is the same type of form that you've used in exponential equations. Like I said, the only thing we're doing differently here is our base is now all going to be the same. It's going to be E. Okay, so now let's take a look at what A, R, H, and K actually mean. First, let's take a look at A. So remember, A is going to be what gives our graph a vertical stretch okay, or a vertical compression. So the S is for stretch and the C is for compression. Remember the H value, this value right here, that is what's going to give us our horizontal shift. Okay, that's what moves our graph left. That's what moves our graph right. And remember, since it's in that parentheses, you always want to make sure that it is the opposite. So if this is a negative, it's moving right. If it's a positive, it's moving left. So be careful with that. Always make sure right here that your coefficient in front of x is also 1. So that's why those parentheses are important. Your k value here, this is your vertical shift. And that is basically what moves your graph up or down. So this is not anything different than the exponential functions that you've already done. All right, so then what does the R value do here? So your R value, remember, that is going to be your horizontal stretch or your horizontal compression. So the S is for stretch and the C is for your compression. And remember that for your vertical stretch, that if your A value is between -1 and 1, basically a fraction that's smaller than 1, then it's going to be a vertical compression and it's a vertical stretch if your number is bigger than 1 or less than -1. Remember, it's the opposite for your horizontal. Okay, so for your horizontal, it's actually a stretch when the absolute value of A is bigger than 1. It's a compression when A is between -1 and 1. All right, so what I would like you to do next is let's just take a minute and we are going to graph our basic or our parent exponential function with e as a base on our graphing calculator, or you can also use Desmos. So what you're going to want to do whenever you graph this is you want to graph your y-intercept and 2 other points that are on your graph, and then we're just going to answer the questions about the basic graph, the basic portions of your parent function. All right, so first let's just graph let's take a look at what A, R, H, and K are, and then we'll go ahead and graph it. So remember, A is your number in front of E. In that case, this is 1. R is your number in front of X, your coefficient of X, or the number outside the parentheses. In that case, this is 1. H, moving left and right is 0. My graph is not a transformation. K, the number over here is up and down. That's also 0. It hasn't moved. All right, so now let's just take a minute and go to Desmos and let's just graph y equals e to the x. All right, so number 1, let's take a look at our y-intercept. Okay, our y-intercept is 0, 1. And then when you graph this, just pick 2 other points that are on your graph. So for example, right here, this one is 1. I can just pick 1, about 1, and 2.718. Okay, so there's a point that I can graph, and then I can pick another point up here. I can pick 1.57, 4.807. So just all you're going to do is write those points down from Desmos or your graphing calculator to graph them. But this is your general shape of your exponential function with e as your base. The y-intercept is always going to be 0, 1, and notice when you plug in 1, that is going to be your 2.718, okay, because you're plugging in e to the first, and we defined e to be 2.718. So it makes sense if I plug in 1 that my y value is going to be 2.718. All right, so let's take a look a second and let's graph that. Okay, so we graph 0, 1, and then 1, 2.718. And then let's just go ahead and graph what that looked like. All right, now let's talk about a couple things here. Let's talk about the domain, the range, or asymptotes, and decide whether or not it's growth or decay. So number 1, since this is an exponential function, we know the domain is going to be the same. So that's going to be all real numbers or -infinity to infinity. Now remember, your range, you're always going to have a horizontal asymptote for an exponential function. The number over here, remember your h is the exact same thing as your horizontal asymptote. So in this case, since I have a 0 here, my horizontal asymptote is going to be y equals 0. And that's going to help us find our range. So this graph is never going to go below 0. All right, so my range here is going to be 0 to infinity. And make sure that you don't use brackets here, that you're using parentheses, because it's never going below that horizontal asymptote. Now let's take a look at this one. Look at my graph. This is an exponential growth, since over here it's growing towards infinity. Okay, my base of e is also bigger than 1, so that helps to tell me that it's a growth function. And then let's take a look at our end behavior. So as x approaches infinity, where's your graph going? It's going towards positive infinity. As your graph is going towards negative infinity, notice here that it's going towards your horizontal asymptote. So in that case, it's going to be 0. So usually one of your end behaviors is going to follow your horizontal asymptote. What I would like you to do is on the next page, just take a couple of minutes. I would like you to try these practice questions, and in the next video, go ahead and check your answers to see how you did. You can use Desmos or your graphing calculator to get some general points, but what I want you to do is, using your knowledge of exponential functions, try to think of what the general shape of what your graph is going to look like before you graph them.